It looked like an ordinary car, but it was hiding a trick no one expected. When testing began on the streets of Silicon Valley, what caught everyone's attention wasn't just its compact design, it was the way it seemed to see danger before it even happened. The Tesla Model 2 debuts with a technology that to many might sound like the stuff of science fiction: vision-guided airbags. Unlike traditional systems, which wait for sensors to detect the force of an impact before reacting, this new system uses cameras to anticipate the inevitable. It's as if the car had instincts of its own. Milliseconds before a collision, the airbags are already preparing, buying precious time to inflate and protect the occupant at the exact moment the body begins to move. This time, saving is almost imperceptible to a human, but it can make all the difference in a frontal collision. Normally, airbags need to identify the force of the impact, calculate the damage, activate the inflation system, and complete all of this in less than a tenth of a second. Now, with camera-based anticipation, the airbag begins inflating at the optimal stage of the collision. This means less direct impact to the head and chest, more efficient force absorption, and a lower risk of internal injuries. All this without eliminating traditional pressure sensors. They're still there, but now work in sync with computer vision, which complements and anticipates decisions. This fusion of image and sensors creates a new level of responsiveness. While in older systems, decisions depended exclusively on physical data, here the car already understands what's about to happen just by looking ahead. This allows the hydraulic system to act quickly, opening valves and activating safety devices with extra time. It's as if the car has watchful eyes and a mind dedicated solely to your protection. And most interestingly, this feature is already integrated into the new software version, demonstrating that Tesla has prioritized safety from the source code. Of course, there's no point in having incredible airbags if the passenger can't get out of the car in an emergency. And that's where the Model 2's other new feature comes into play: one-button door release, which works even without power. It may seem like a small detail, but there have been real reports of parents breaking windows to save their children trapped in previous models after auxiliary battery failures. This revealed a flaw that wasn't a user error, but a design flaw under pressure. The new solution aims to completely eliminate this kind of anguish. The idea is simple and brilliant: create a single point of interaction that works in any situation. With power, the button activates the latch's motor. Without power, that same button activates an integrated mechanical mechanism. No hidden levers, no sequence of steps with tools. The button is positioned where your hand would naturally reach, and the action is the same, with or without a battery. This transforms a moment of panic into an instinctive reaction, something even a child can easily understand and replicate. On the outside, the story repeats itself. The door handle was designed to maintain some aerodynamics without compromising emergency use. Even without power, it's as easy as pulling, just like in older cars. The difference is that inside, everything has been reconfigured to unify the electrical and mechanical pathways. This requires careful engineering to ensure the systems don't cancel each other out, but rather collaborate. The result is a door that opens with the same natural ease, regardless of the car's condition. And even with so many changes, the door's strength remains untouched. Safety tests, such as FMVSS 206, require the latch and hinges to withstand pressure from multiple directions, and the Model 2 easily meets these requirements. In other words, ease of opening doesn't compromise protection in the event of an accident. On the contrary, it improves the chance of a faster escape or a swift rescue. In short, the design embraces engineering complexity, but delivers simplicity when it matters most. What's most striking about all this is that these changes aren't just aesthetic or technological. They directly tap into human instincts. The fear of being trapped, the anguish of seeing danger approaching and having no control. The Tesla Model 2 responds to these sensations with intelligence, anticipation, and human-centered design. And in doing so, it transforms every button and every millisecond into invisible allies, always ready to act when you need it most. When it comes to side collisions, most drivers only think about the dull sound and force of the impact. But what happens inside the car's structure in the first few milliseconds can be the difference between a scare and a tragedy. The Tesla Model 2 takes this seriously, with a 3-stage lateral absorption system that acts like smart armor. The structure was designed as an energy path, guiding the force of the collision along controlled paths, and it all starts with the door. Inside, an internal steel beam is the first to face the impact, deflecting the blow to reinforced areas, like the lower side member. This beam, which runs along the lower part of the car's side, isn't just a metal bar. It's designed with carefully calibrated deformation zones. These act like shock absorbers that progressively crush, absorbing energy and buying time for the occupants. The key here is balance. It's rigid enough to support the initial load, but flexible at just the right points to absorb the impact without transferring it directly to the passengers. This prevents the door from invading the seat space and preserves the time needed for the side airbags to deploy accurately. The third layer of this invisible shield is the battery pack's contour. Many people don't realize it, but the battery's outer structure also helps absorb impacts. It acts as an additional longitudinal bar, redirecting the force along the length of the car. This prevents the impact from concentrating on vulnerable areas, such as the ends or corners of the battery cell, and helps protect not only the occupants, but also the vehicle's electrical integrity. A misdirected impact can cause much more than just dents. It can mean a fire or total loss. Between the side member and the pack, Tesla inserted absorption elements that further soften the impact. These inserts act as buffer zones, transforming a blunt impact into a gradual movement. It's as if the force of the impact is decelerated within the structure, making everything more controllable for the internal components. Tesla created a kind of internal damping effect that better distributes the load and reduces the force spikes that typically destroy the geometry of seats, rails, and even seat belt buckles. To complete the force path, engineers added support beams under the floor. These transverse reinforcements help carry lateral force from one side to the other, rather than concentrating it all at a single point. This clever deflection reduces the rate of intrusion into the cabin and protects the structure surrounding the occupants. In other words, the car not only resists the impact, it directs it away from people. And this millimeter-by-millimeter engineering also reduces post-accident damage, shortening repair time. With less floor deformation and less structural deviation, the side airbags have more room to deploy correctly. They deploy in a more predictable environment, increasing efficiency and reducing the risk of failure or incorrectly inflating. This also facilitates the work of the seatbelts, which keep the body in the ideal position to safely absorb the force. The result is a cabin that acts as a protective cocoon in often chaotic situations, and the impact doesn't stop at the moment of the crash. This system also directly influences repairs. With the structure absorbing and directing force more efficiently, the number of parts that need to be replaced decreases. This means lower maintenance costs and reduced repair time, essential for those who depend on their car daily. Instead of complex changes to the main structure, adjustments in specific standardized areas are sufficient. Ultimately, all this engineering has a very clear goal: to prevent the unexpected from becoming the irreparable. Each stage of the Tesla Model 2's lateral deformation is like a shield that intelligently bends. It's not just a car absorbing the impact, it's a car that understands the path of the force, chooses where it goes, and does everything to prevent it from reaching where it matters most: the human body. If there's one part of a car that suffers silently with time and impacts, it's the door frame. It sits there quietly, connecting the A, B, and C pillars, and rarely gets the credit it deserves. But in the Tesla Model 2, this area has become a protagonist. The brand invested heavily in a new type of structure, a hot-stamped steel ring with variable thicknesses. This part, known as a door ring, functions like a steel belt that surrounds the entire door space. The trick lies in how it distributes weight and rigidity, reinforcing critical areas and relieving stress in less stressed areas. By utilizing multiple steel sections with varying thicknesses and strengths, Tesla created a single component that's stronger where needed and lighter where possible. For example, the areas near the hinges and latches receive thicker material, better withstanding the forces of opening, twisting, and impact. Meanwhile, the intermediate sections, where less load is carried, are thinner, contributing to weight reduction. This not only improves structural performance, but also aids energy efficiency, as the car carries less mass in motion. But the real magic lies in how this ring behaves in a collision. Instead of allowing the force to concentrate on a single point, as happens in simpler structures, the door ring distributes the energy across multiple paths. This reduces the risk of localized failures, increases the car's torsional rigidity, and helps maintain the roof's shape in the event of a rollover. In other words, the Model 2 is stronger without feeling like a heavy suit of armor. Engineering has found a balance between lightness and strength, something that makes all the difference in safety and drivability. And this balance also impacts daily use. You know that feeling when an older car's door doesn't close properly after a few years? With the Model 2, that tends to disappear. Because the structural ring better distributes stress, the car maintains its shape and dimensions for much longer. The doors remain aligned, the gaps remain uniform, and the closing sound remains solid, even after many cycles of use. All of this contributes to more efficient sound insulation and greater cabin comfort. Another interesting point is that the system helps preserve the performance of safety systems over the years. Because the doors maintain their alignment, the sensors, locks, and seals operate within optimal parameters. This avoids the fine-tuning that many cars require after a period of use. With Model 2, the structure is so precise that margins for error are virtually eliminated. This means less maintenance, fewer unwanted noises, and more confidence in everyday use. The manufacturing method is also noteworthy. First, the different types of steel are joined by laser welding, forming a single, custom-made sheet. Then, this sheet is hot-stamped, achieving strengths ranging from 1,300 to 1,500 megapascals. This combination ensures not only strength, but also dimensional accuracy. The final part leaves the factory virtually perfect, with fittings and geometries designed to maintain the vehicle's integrity for many years to come. Furthermore, the ring's rigidity benefits the door opening and closing systems. Because the hinge and latches attachment points are attached to an extremely stable structure, there's less risk of misalignment, even after light impacts or prolonged use. This ensures that the doors continue to open and close smoothly, without sticking or requiring constant adjustments. A practical benefit that may seem simple, but it directly influences the user experience. Finally, it's worth remembering that this innovation also has a direct impact on safety inside collisions. Thicker sections block initial intrusions, while thinner ones deform in a controlled manner. This creates an internal environment where airbags and seatbelts function exactly as designed, without unexpected interference. What appears to be just a reinforced frame is, in practice, a strategic shield that protects the lives of those inside every day. The first impression of the Tesla Model 2's bumper is simplicity. But this simplicity is deceptive. Behind the clean, functional appearance lies a modular, three-layer system designed to handle light to medium impacts with extreme efficiency. The structure consists of a main beam, two tubes known as crush cans, and an energy-absorbing foam block. This combination not only protects the occupants and the car's interior components, but also dramatically reduces the time and cost of repairs after minor accidents. It's as if the bumper were a smart, detachable shield. The operation follows a well-thought-out logic. In low-speed collisions, like those minor bumps in parking lots or traffic jams, the front foam kicks in. It gently compresses, absorbing the impact and preventing the force from reaching more rigid structures. In slightly stronger impacts, the crush cans bend in a controlled manner. They have predefined collapse zones, like internal hinges, which absorb the impact energy without allowing it to reach the most important part of the front of the car, the engine compartment and structural frame. And here's the difference. This structure is entirely bolted together. No welding or permanent joints are required. In the event of a collision, simply remove the bumper, disconnect the sensors, unscrew the crush cans, and replace the damaged parts. This process is much faster than traditional repairs that require aligning the structure or using traction machines. And, because it's modular, it ensures that the radar and camera sensors return to the exact same locations, maintaining the accuracy of driver assistance systems. It's not just a quick fix. It's a repair with pinpoint accuracy. Furthermore, the choice of materials was also carefully considered. The main beam can be made of high-strength steel or extruded aluminum, depending on the model, always seeking a balance between lightness and strength. The crush cans are thin-walled tubes with strategic grooves that guide the collapse evenly. This prevents them from coming into contact with the powertrain or deforming more sensitive components of the car. And the foam block, usually made of EPP or a similar material, has a very useful feature. It can absorb and return to its original shape even after very light impacts, avoiding even minor damage. From a maintenance standpoint, this approach is a relief for car owners. There's no need to disassemble half the vehicle to replace a bumper. Time spent in the shop is reduced, and so are costs. Even in more serious collisions, the fact that the parts are removable and replaceable prevents the notorious snowball of cost overruns. And because the parts follow fixed standards, Tesla ensures that any authorized repair shop can perform the service quickly and safely. It's a model that benefits the user and relieves the burden on repair centers. In practice, this means less bureaucracy with insurance companies, less time without a car, and fewer headaches. Modularity also helps with inventory and parts logistics, which should translate into lower prices in the long run. And of course, because the entire system was designed to preserve the car's sensors and systems, the chance of needing to recalibrate cameras, radars, or parking sensors is much lower. The Model 2 doesn't just protect the driver in an accident, it protects your wallet too. Another important detail is the precision fastening. The anchor points have holes and fittings designed to maintain the original alignment even after replacement. This ensures that the system continues to function as it was tested in the laboratory, maintaining the integrity of crash tests and factory technical parameters. The idea is that, even after a repair, the car remains as safe as the day it rolled off the assembly line. No more compromising safety due to a minor bump. This engineering, which combines intelligent absorption, ease of maintenance, and structural precision, shows that the Tesla Model 2 goes beyond appearance. Every part was designed not only to protect, but also to make life easier after something goes wrong. Because, ultimately, more important than avoiding an accident is ensuring that, if one does occur, the consequences are minimal for the car, the driver, and everyday life. For decades, 12-volt electrical systems dominated car interiors. But as technologies became more complex, this voltage began to show its limitations. Thicker wires, excessive heat, and connector failures became part of the daily routine for many drivers, even in modern models. The Tesla Model 2 breaks this cycle by adopting a 48-volt architecture specifically for its door systems. It seems like a small change at first glance, but the difference is profound. The new voltage reduces the electrical current required to operate the same devices, which means less heat, less wear, and much greater efficiency. The physics behind this is simple. Power equals voltage times current. By quadrupling the voltage, the required current drops to a quarter. With less current flowing through the wires, electrical resistance, which generates heat, drops. This makes wiring harnesses thinner, lighter, and less prone to failure due to overheating. The immediate result